Hi guys, Mark here, and today we're looking at how we can solve day 14 of the Advent of Code challenge. And today it's all about reindeer races. By the way, apologies if you can hear that motorbike in the background. I've been waiting ages for it to stop, but it doesn't seem like it's going to. So anyway, the reindeer races, we have a bunch of reindeer and they can all fly very fast, but only for a short period of time, and then they have to have a rest. So Comet can fly at 14 kilometers per second for 10 seconds, but then has to rest for 127 seconds. And they're going to have a race, and the race is going to be, how long? 2,503 seconds long. So we basically need to find out how far each of the reindeers have got in that time and see which one got the furthest. And so let's start off looking at this in C#. Now the code I'm going to show you isn't my initial solution. My initial solution was a little bit ugly, and so I have spent a little bit of time trying to refactor this and make this a little bit nicer. Finally the motorbike goes away. Right, so we're starting off by reading all the lines from our input file, and I did try a regular expression to parse them, but actually life is a bit simpler if we just split the string on spaces and pick out the elements that we need. It turns out that for this problem we don't actually need to know which reindeer won. We just need to know for each reindeer what their speed is, how long they can go at that speed for, and how long they need to rest. So once we've got all the reindeers, for each reindeer we're going to create an array that contains how far they've got up to every second. Now we don't actually need this for part A, because part A we're just looking for which is the winner, and so we only need the total distance they covered. But we do need it for part B, and so that's why I've taken this approach. So I do an enumerable.range that basically has one element for every second with an incrementing number. And then for each of the ranges we're working out how far they can go in that second. And that's done fairly simply by some modulo arithmetic. We modulo the current second number by the total time of the reindeer flying and resting, and if it's less than the time flying then they're going at full speed, otherwise they're going at 0 speed, they're having a rest. And so this will give us a sequence of how far they travel in each second. What we want is a running total, and we can do that with another Morlink method. And Morlink has of course been making lots of appearances. Morlink scan is a great way of getting a running total. What you do is you provide a starting value, so they've gone a distance of 0 kilometers, and then for each element in the sequence you take the accumulator, how far they've gone in total, and how far they went in the next second, and we just add them together. And then I skip over one because this sequence will start with 0, and we don't actually want to include the starting point in this sequence, otherwise for part B every reindeer will get an extra point. And then we convert that to an array, and we convert the whole thing to an array. So we've got an array of arrays. Let's just use LinkPad's dump method to write that out to the LinkPad result window. And so you can see our array has got 9 items in it, and each of those 9 items, it's one for each reindeer, has got another array showing how far they got to after each second. And so the first reindeer, Rudolph, probably got 27 kilometers after the first second, then 54, then 81, and then here you can see now he's having a rest, and we have to scroll down quite a way before he gets going again. And here he's got a bit further and he's having another rest. So with that lookup in place, we're now positioned to solve it. For part A, we just want to see in the 2,503 seconds which reindeer got the furthest. And we can do that by looking up for each row in our lookup table, find the maximum of the last element in that row, which is the total distance each reindeer got. So that's nice and easy. What about the second part? Well, the second part, basically, what Santa does is at the end of every second he sees which reindeer is in the lead and he gives that reindeer a point. And if they're tied, each of the ones in the lead gets a point. So Again, we're finding the maximum, but what we're doing is for each reindeer, we are selecting for each second, and we're using the 2-parameter version of select here so that we get the distance that they've gone at that point, and t, which is the number of seconds, so that'll be incrementing. And if the distance they've gone is the maximum out of how far all of the reindeers have gone in that second, then that means that they are in the lead, so they get a point. Otherwise they get no points. And so we then sum that together, and this is going to give us, for each reindeer, this nested select, this is going to give us how many points they got in total over the 2,503 seconds. And so that gives us our answer. And like I said, actually this problem doesn't require us to find out which reindeer won. Otherwise, we would need to be feeding a little bit more state through these link expressions. Let's have a quick look at how I solved this in F#. I actually took a very similar approach. The only thing I did that was slightly different was broke out a couple of helper methods. So I had this distance method that, given a reindeer's speed, duration they can go at that speed, and resting time, and what second we are currently on, it works out how far the reindeer goes in that second. And then I've got another helper method that calculates the progress of the reindeer over a specified number of seconds. And so what I do is I create a sequence from 0 to the number of seconds minus 1. I then map that into my distance function to find out how far they go. Then we're using scan. F# has got scan built in, and we can use this nice syntax just with plus as a function to keep a running total, starting with 0 as the seed value. Like C#, we do have to skip the first one, and then we can convert it to an array. And so then parsing the input, well, that's going to be very similar to what we just saw in C#. Read all the lines from the files, split it on space, pick out the 3 things of interest and cast them to integers, and then map that over our progress function to get an array of arrays of how far each reindeer went in each second, or what distance each reindeer got to in each second, I should say. And so to solve part A, we take our lookup. We, for each reindeer, get the total distance they travelled by looking at the last element in the array. We find the maximum out of all those total distances they travelled. For the second part, again, it's similar to the way we did it in C#. We use seek.mappy, which is like C#'s select, with 2 parameters, one for the index. And we look to see if the value of at this second for this reindeer is equal to the maximum value that any reindeer is at for this second. And I should have said, really, when we were talking about the C# code, this is a little bit inefficient because it means for every reindeer we will calculate which reindeer was in the lead that second another time. So we'll 9 times every second we'll be calculating which reindeer was in the lead. But really it's only 9 reindeers, so it's not too much of a problem. And if they're in the lead, they get a point, otherwise they get no points, and we sum that together. And that is my function for working out how many points a reindeer gets. And you can see here I've made a little helper called smax. One of the unfortunate things about F#'s max function, unlike C# and link, is that you can't pass a selector method into the seek.max method. And so just to make the F# code a little bit more concise, like the C# code can be, I have used this function composition that says take a mapping function, map our sequence through that function, and then pass that into sequence.max. And so here we're working out the maximum of all the reindeers times at time t, and here we're working out the maximum of all the points of each reindeer. So anyway, that was my solution for day 12. I will post the code onto my blog at markheath.net, and hopefully I'll see you for day... Did I say day 12? It's day 14 now, and hopefully I'll see you for day 15.